In this video, we're going to be talking about the special relationship between slopes of parallel lines and slopes of perpendicular lines. Once you learn this special relationship, you can use it to help you solve more complicated problems that you'll see in the future. So let's talk about the relationship of parallel lines and their slopes first. Use this example. We're given the coordinates for A and B, and we're going to find the slope of line AB. Then we'll use the coordinates C and D to find the slope of line CD. We'll compare the two slopes and try and figure out this special relationship. To find the slope of line AB, we're going to use our slope formula. We'll find the difference in the y coordinates over the difference in the x coordinates. So here we go. For line AB, the slope is difference in the y coordinates, 2 minus 5 on top, over difference in our x coordinates, negative 3 minus 2. So on top we get negative 3, on the bottom we get negative 5, and simplify a negative divided by a negative to get a positive slope of 3/5. Alright, let's look at line CD and find its slope. Again, we'll find the difference in the y coordinates, 2 minus negative 4. Don't forget the negative and the negative symbol here. The subtraction and the negative symbol are different. Include them both. Find your difference in your x coordinates, so 8 minus negative 2. So on top we got a double negative that turns into addition, so we got 6 on top. Again, on the bottom we have a double negative which turns into addition, so we got 10 on the bottom. And if we reduce and divide the top and the bottom by 2, then we get a slope of 3/5. So as you can see that the slope of line AB and the slope of line CD are equal. Let's plot these points and try and get a visual. There's point A and point B. Here's point C and point D. Kind of connect those lines if you can, as straight as possible. If I could draw my lines a little better, we could actually prove that line AB and line CD are actually parallel. But really what makes them parallel is the fact that their slopes are equal. If I have two lines that are changing in the exact same way, they're rising and running in the exact equal manner, they will never intersect and they will indeed be parallel lines. So slopes of parallel lines are equal. Or you could say they're the same. Slopes of parallel lines are equal or the same. You might use that information for a more complicated problem in the future that talks about intersections of lines. And if you're looking at two equations for lines and you notice that their slopes are equal, you don't really have to go any farther because you know that parallel lines will never intersect, and then therefore you could say the solution to that problem was no solution. We'll see that in the future. Alright, let's talk about the relationship of slopes of perpendicular lines. So let's use another example similar. Given two coordinates for A and B, two coordinates for C and D, we'll find the slopes and compare them. So different line AB this time. Let's find the slope. Find the difference in our y coordinates. This is going to be m equals negative 5 minus 2. And the difference in the x coordinates, negative 2 minus 3. And so that gives us on top negative 7 and negative 5. And again, negative divided by negative simplifies to a positive 7/5 is our slope for line AB. It's kind of messy. That says m equals. Alright, let's find the slope for line CD. slope equals, difference in our y-coordinates, -3 minus 7. And difference in our x-coordinates, 10 minus -4. On top, we get -10. And on the bottom, double negative becomes addition, so we get a +6. Sorry, +14. Erase that. Said it was addition. There we go. And if we reduce this, if we divide top and bottom by 2, we get -5/7. Now, how do these slopes compare? First of all, hopefully you can recognize that one is just the reciprocal of the other, meaning it just got flipped upside down. But then the top slope, the slope for line AB was positive, and the slope for line CD is negative. So not only are they reciprocals, but they're called opposites. Anytime you have a positive and negative, those are opposites. So two traits or two characteristics, and they both have to be true every time. The slopes of perpendicular lines are opposites and reciprocals. Or you could call them opposite reciprocals. Reciprocals. Make sure we spell it right. So not just one, not just the other, but always got to be opposites and always got to be reciprocals. If they are both, then we know that these lines are perpendicular. Let's look at a visual. Let's plot these points and just make sure. There's our point A. There's our point B. Here's C. And here's D. If I try and connect it as straight as possible here, that's pretty good. Then we can see that we're creating a T shape. That's a good symbol for perpendicular, which also means that this intersection right here is going to create 90-degree angle or a right angle. And so some more complicated problems you might see in the future might involve angles and equations of lines. And so you know that if the slopes of two lines are opposite reciprocals of each other when you're looking at their equations, you know that the two lines are going to intersect in a perpendicular fashion, and they're going to create a bunch of right angles, which you may be able to use to your advantage. All right, so there's the two special relationships. Again, know these. They'll come back a lot in math. Slopes of parallel lines are equal or the same, so those two lines will never intersect. And slopes of perpendicular lines are opposite and reciprocals, or opposite reciprocals, and they will intersect in a perpendicular type of way, creating right angles. All right, so in the next few lessons we'll talk about intersections of lines. They don't have to intersect in a perpendicular way. We could have lines that cross in any way. But for today, slopes of parallel lines, slopes of perpendicular lines. Hopefully you can tell the difference. Good luck.